What if we're trying to figure out an inverse trig function, but our answer needs to be an angle outside of standard unit circle angles, such as angles bigger than 2 pi, bigger than 360, or less than 0 pi. That's what we're going to tackle today, this lesson. Remember what an inverse trig function is? You plug in a ratio, you get an angle back. Now, this angle for this lesson is going to be an extreme angle, meaning outside of the normal range of 0 to 360. Remember these identities. Cosecant inverse of x is sine inverse of 1 over x. Secant inverse of x is just equal to cosecant inverse of 1 over x. Cotangent inverse of x is equal to tangent inverse of 1 over x. This just helps us because if we know the sine inverse of something is the same as the y value, we can just look at the y value on the unit circle, and that will give us the angles. Same for cosine. If we know the cosine, that's the x value of the point, and locating that point, we then can associate with an angle. And inverse, we need to know our tangent unit circle, which consists of 1 square root of 3's and square root of 3 over 3's, and variance. And of course, 0 and undefined. Okay, so let's get to the gist of this with example 1. Notice right off the bat, well, first of all, sine inverse of 1/2, okay, but it's for this interval. It's in angles that are between negative 2 pi and negative pi. Well, that's kind of tricky, right? So these are not angles that are standard. However, step 1 is going to be very similar. Make sure that this says either sine inverse, cosine inverse, or tan inverse. If not, we'll use those identities to convert them. Step 2, determine the coordinates on the unit circle associated with those given trig values. So this is just unit circle, right? So where on the unit circle does y equal 1/2? Well, it's going to be at pi over 6, right, or 30 degrees, and at 5 pi over 6, the y value will be equal to 1/2. Again, we can look at our unit circle and verify that. Sine will be 1/2 of both pi over 6 and 5 pi over 6. So that gives us the two angles on the unit circle, or standard angles. However, those two angles do not fall between negative 2 pi and negative pi. So step 4 is to write our range with common denominator. This is what kind of tricks up a lot of students, but notice that the answers we got were in terms of pi over 6. So that means what we can do is we can take our original range and write it in terms of pi over 6 and go from there. So if we multiply this by 6 over 6, we get negative 12 pi over 6, the same as negative 2 pi. If we multiply this by 6 over 6, we get negative 6 pi over 6. Why did we do that? Well, now, instead of worrying about the denominators, we can just look at the numerators and know that our answer for our numerators must fall between negative 12 pi and negative 6 pi. Now we're going to add or subtract 2 pi from our answer so that it falls within the expected range. So we need to ensure that pi over 6 is within this range. We will subtract 2 pi from it, which is the same as what? Going 360 degrees counterclockwise, in hopes that the new angle will be within this range. Remember, adding or subtracting 2 pi from the angle will not change the point on the unit circle associated with that angle because you will land in the same spot. So let's take pi over 6, subtract 2 pi. By doing that, it's basically subtracting 12 pi over 6, right? And so pi over 6 minus 12 pi over 6 is negative 11 pi over 6, which does fall within our original range, which was negative 2 pi to negative pi. And that's why we converted it to pi over 6, because now we can easily see that this negative 11 pi numerator is in between negative 12 pi and negative 6 pi over 6. So what that means is, this negative 11 pi over 6 angle is going to work because it's the same as pi over 6, the angle that we found, which is standard on the unit circle. Now let's do the same thing for 5 pi over 6. So the question is, how does this 5 pi over 6 how does this fall within our range of negative 2 pi to negative pi? Well, again, we've already written that range in terms of pi over 6. So all we have to do is take the 5 pi over 6 and make sure and convert it to an angle that falls between these two angles. So we're going to subtract 2 pi from 5 pi over 6 in hopes of landing within this range. If we subtract 2 pi, again, it's the same as subtracting 12 pi over 6, which is negative 7 pi over 6, and this new angle falls within the expected range. Negative 7 pi over 6 is exactly the same as 5 pi over 6. All we did was subtract 2 pi. Subtracting 2 pi is the same as going 360 degrees clockwise. You end up at the same point you started with. So because 5 pi over 6 is the same as negative 7 pi over 6, and that means the y values are the same. Namely, the y value is going to be at negative 7 pi over 6 would be the same as 5 pi over 6, 1/2, because they're the same angle. Here's what negative 7 pi over 6 would look like as an angle. Let's go just like that. That would be negative 7 pi over 6, same as 5 pi over 6 for the y value. So what that means is sine inverse of 1/2 are these two angles, which we got from subtracting 2 pi from angles that we already know on the unit circle. Those two angles were 5 pi over 6, we subtracted 2 pi from it, and pi over 6, we subtracted 2 pi from that, and we got these two angles. And we ensured that these two angles were within the range that we were asked to be given. Answer in. So that's it. Sine inverse of 1/2 is equal to negative 7 pi over 6 and negative 11 pi over 6. Two angles that are in between negative 2 pi and negative pi. Again, going back visually, you can't do that enough. Negative 2 pi would be, let's actually do this with the unit circle. Negative 2 pi would be going all the way around and starting right here. And then our endpoint, negative pi, would be right here. So the range we're working with is this orange line. All right, that's it for this first example. If you have any other questions about it, let me know.